Hey guys, how's it going? It's Richard here. So today I'm gonna comment on the alum crystal growth. So far as you can see from this little file here, the crystal has been growing quite a lot. You can see there are a lot of crystals like on the wall of the little vial and as well as on the bottom of the vial. So, what might be affecting the crystal growth is the room temperature and then the air flows. Because the room temperature, as temperature increases, the rate of evaporation increases, and then the air flows. If the air flows like faster, then its exchange with air is like faster. So there are more water molecules that is like able to be brought into the air. So yeah, and then now I'm gonna talk about the percent yield of the experiment. First, I'm gonna talk about the theoretical one, and then I'm gonna talk about the actual one. So, we started the experiment with 1.006 grams of aluminum foil, and then the way I calculate the final product is list all the equations out first, as you can see from right here. So once you have the chemical formulas, and then you can compare the molar ratios of the elements in order to figure out the final product. So we start off with aluminum and hydroxide, and then we have like aluminum hydroxide ion, and then some hydrogen gas. So for this part, the mole ratio of the reactant and the product is 1:1. And then if you bring 1 to the next equation, where aluminum hydroxide reacts with sulfuric acid, you can get aluminum hydroxide precipitate, water, and sulfate ions. And then in this one, as it's 2:2, the original ratio is still 1:1. So if this is x, then when it's here, it's still x. And then the next equation is aluminum hydroxide reacting with the excess sulfuric acid, and then as you can see, the ratio of reactants is still 1:1. Keep in mind, because like the aluminum here, since the aluminum sulfate is soluble, so really this is 2Al, which is like 2 aluminum ions here, so the molar ratio of those two is still 1:1. So x here, and then x will still be here. And then finally the last one is the form of alum crystals, and then the ratio between alum and the alum crystal is still 1:1. So how many moles of aluminum we start with, in the end we're gonna get how many moles of alum crystal. So in this sense, since we started 1.006 grams of alum foil, then the ratio is 1:1, and then we calculate the moles of aluminum with the amount of aluminum foil we used divided by the molar mass of aluminum, and then we calculate the mass by multiplying the same mole with the molar mass of the alum crystal, which is this long equation here. And then finally our theoretical yield should be 17.69 grams. And then from the experiment, our actual mass, luckily, is 3.203 grams of alum crystals. So our percentage yield is 3.203 over 17.69 times 100%, which is 18.11%. It's a fairly small number. The reason why we get such a small amount of yield is the rinsing error. So when we're doing the experiment, we added 25 milliliters of water to rinse the aluminum foil pieces from the into the solution, and then inhibited the formation of alum crystals. And then at 0 degrees, the solubility of alum crystals is around like 2.5 grams per 100 milliliters of water. I should elaborate on the paper here. But then there also might be other substances in aluminum foil, which means like the aluminum is not it's not pure. And then when we were vacuum filtrating the first time through, we actually didn't let vacuum in. It's just like air inside. So I think that constituted most of the problem to our percentage losses, because I think a lot of like the solution actually didn't go through. Anyways, that's about it, and thanks for watching.